Okay, so we are making the rational functions cheat sheet. Why are you guys so giggly? You're like, this feels like a trap. If I repeat her, then I said it. Alright, so the first thing that we did this unit is we simplified rational expressions. So that I can get my hand out of the way so you can see it. Okay, so simplifying rational expressions, that's the very first thing that we did. And there were basically 3 important things we needed to take away from that day. And the first thing we needed to take away was that anything with a plus or a minus is one group. So anything with a plus or a minus in it is a group. The next thing that we wanted to take away from that first day was that we have to factor everything. So we keep having these assignments where if you have not factored several times in the assignment, you've not done it correctly. All right? When you get to the test for this unit, if you did not factor all the way through the test, I can almost guarantee you failed the test. All right? Because these tests, this quiz, every assignment, this whole unit, there's factoring everywhere in these assignments. All right? This unit might as well have been called factoring every day, because that's all we do. All right? So factor everything. The last thing is that we can cancel out tops and bottoms. So factors that are on the top that are the same as factors that are on the bottom, those will cancel out. And the reason that they cancel out is because they divide to be 1. And that's a good thing to remember, just to know why you're able to cancel things out. It's because 5 divided by 5 is 1. Or x plus 3 divided by x plus 3, that also equals 1. X squared divided by x squared also equals 1. So anything that's the same on top and bottom divides to be 1. All right. Now, a lot of you guys, when you made your cheat sheet, a lot of you guys would write something like this and say, okay, that's good. That's all I needed for day 1. Let me start writing about day 2 on my cheat sheet. But this sort of thing, by the time we get halfway through the semester, you're probably not going to remember what this means anymore. And so we want to make sure on our cheat sheets we always put example problems. Because the example is you going like, oh yeah, I can do that. So we're going to go ahead and put an example next. And we're going to say that the instructions for this example are to simplify. And this unit is kind of a rough one because all the instructions say simplify, like throughout the entire unit. It's just going to be like simplify, and you're going to have to know how to simplify these different types of problems, okay? So that's why the cheat sheet will come in handy. So the problem we're going to look at is x squared plus 9x plus 20 divided by x squared plus 13x plus 40. So how do we simplify this? Factor, right? I can see that there are pluses and minuses in this problem, so that means the entire top is one group, the entire bottom is another group, and since those two groups are not identical to each other, we cannot cancel anything right now. All right? So at this point, we've got a factor. So how do you factor the top and bottom? What's the method we're going to use? Diamond, yeah. So we're going to say what multiplies to 20 but adds to 9. 5 and 4. And then for the bottom, we're going to say what multiplies to 40 but adds to 13. 8 and 5. All right, what do we do next? Yeah, this x plus 5 and x plus 5, those divide to be 1. So x plus 5 divided by x plus 5, they divide to be 1. So I will go ahead and cancel those. And then what do we have left over? All right, we did another thing that first day. We also looked for excluded values in problems. Do you guys remember where the excluded values came from? Yeah, you equal something to 0. What do you equal to 0? The denominator, yeah. So excluded values come because the denominator cannot equal 0. The denominator cannot equal 0. So that's where our excluded values come from. So we're going to say that excluded values are numbers. Excluded values are numbers plugged into the variable that make the bottom equal 0. So excluded values are numbers that you plug into your variables and they make the bottom equal 0. And that's why they're excluded, because you're not supposed to have that. So again, anytime I put something on my cheat sheet, I probably want an example of it, just in case I forget later. I might brain fart on it tomorrow, but I might brain fart on it in 3 months, right? Probably more likely than 3 months I'll have no idea what I mean by this, so an example is always a good thing. So I'm going to go ahead and just take that example that we had written above and use it again. You guys are like, Ms. Rice, my brain doesn't fart. I don't know what you're talking about. My dad used to always call them fluffs. And I'm like, Dad, what are you fluffing? I know, right? Did you say I fluff every day if I have to?
Oh, yeah. If you don't fluff every day,
all right. So we're going to take the bottom. And we're going to say that the bottom cannot equal 0. And we want to solve this equation for x because we want to know what's going to make it equal 0 so we can say, all right, don't use that. So how do I solve an equation that looks like this? Factor. We factor it, right? We factor it. we already factored this equation. We don't have to do the work all over again. So the factors that we found were x plus 8 and x plus 5. So what do we do to keep solving it? Yeah, take each part and say x plus 8 is not supposed to equal 0, and x plus 5 is also not supposed to equal 0. So what are the excluded values that we have? Yeah, x cannot equal negative 8, x cannot equal negative 5. So those are our excluded values. Can't have them. Yeah.
Does that have anything to do with like what we learned a while ago about like figuring out like x values or x-intercepts or something?
Kind of. Yeah.
So isn't it just like changing like the positive or negative?
Yeah. You learned how to solve something by factoring in the past, and when you have it in the factored form, you do take the opposite sign. And this is why it works, because you would have taken each factor and set it equal to 0, and then to move the 8 over, you do the opposite of it, and that's why it's do the opposite. Yeah, it's exactly what you've learned in the past.
But what we learned in the past is we didn't put isn't
Right, because you were actually solving for it. You were saying this equation really should equal 0. What do I get? We're saying we never want it to equal 0, so what would make it equal 0? And then let's not use that. Yeah. Yes?
So we always want to equal to 0 and not when it's factored.
Yeah, so if it's not in factored form, you just don't learn very much from that. You typically have to put it in factored form to figure it out. Yeah, you can do. These are your notes. You do whatever you need. All right. Hey, guys, I had a good question. The question was just, she just wanted to know if she could add something else to her notes, and the answer is yes. If you need, this is like, at the very least, you should have this written down. But if you want to add little notes to yourself to make things make more sense, then absolutely, these are your notes. All right, so we can add more to them and make them more detailed and more helpful for you individually. Okay, we've had one more thing that we've learned this unit so far, and that is how to multiply and divide. So I made it so I have 3 titles on mine. I've got simplifying rational expressions as the first title, and then excluded values as the second title, and then I'm doing multiply and divide as the third one. So on these ones, if it was a multiply problem, we could kind of just get started and do what we've done in the past. But if it's a divide problem, what do we have to do before we get going? Okay, so if dividing, keep, change, flip. I know that some of you guys had learned it from your previous teacher as keep, change, change.
Yep.
And you're welcome to write that down if that makes more sense to you.
I like keep change. I do.
Keep it, change it, flip it. All right. After we do that part, after we do keep, change, flip, the next thing we look for is we say anything with a plus or a minus is a group. So after we do keep, change, flip, we look at the problem, and anytime we see a plus or a minus, we got to put those parentheses in. That's a group. After that, we're going to factor everything. Lots of factoring in these problems, right? We factored the first day of the unit. We factored the second day of the unit. We're about to factor during the third day of the unit. Factor everything. And then the last thing we do is we cancel tops and bottoms. Why can we cancel tops and bottoms?
Because
They divide to be 1. Mm-hmm. Alright, so the instructions for this example are going to have the same command for us. They're still going to say simplify. Simplify this problem. And we've got x squared minus 1 over 4x. And we are dividing that by x to the third. Sorry, I lied. X squared. X squared minus 5x plus 4. And then on the bottom, x to the third minus 16x. So that's the problem we're going to use as our example problem. And this is a division problem, so what's the very first thing we should do? Keep, change, flip. Keep it. Change it. Alright, I went ahead and wrote keep, change, flip underneath to remind myself that's what I did. What do I do next? I gotta factor it, right? So how do we factor x squared minus 1? What type of factoring is that?
Squares.
Yeah, difference of squares. So this one has 2 sets of parentheses, one with a plus in it, one with a minus. So x squared plus 1, it's difference of squares. So what would go in our parentheses? X plus 1, x minus 1. Yeah, you can't factor 4x. That's just already factored because there's no plus or minus in there. So 4x is already kind of like 2 separate factors. How do we factor x to the third minus 16x? X to the third minus 16x. There's a greatest common factor. There's an x there. And then what's left over when you divide out that x? Minus 16, right? Because this was 16. Yeah, and then what do you notice about that? X squared minus 16? That's a difference of squares again, right? So that x squared minus 16 is x plus 4x minus 4. So I'm going to say I still have the x in the front, but I know I was doing difference of squares, and that's one with a plus and one with a minus. And I had x plus 4, x minus 4. And I'm going to go ahead and scribble this one out because I fixed it again. How do we factor the bottom of that? So we're finding something that multiplied to 4 but added to negative 5. So our step on this one was to factor. That's what we were doing that time. Okay? And then what's our next step? Yeah, cancel out tops and bottoms. Anything that's the same would divide to be 1. So what do you guys see that's the same? Okay, there's an x minus 1 and an x minus 1. Yeah. I scribbled it out because I had factored it, but then I factored it a little bit more, and I didn't want to be confused. I wanted to use the most factored version instead of this one that was not all the way factored. All right, what else? So we got an x minus 4 and an x minus 4. I see one more thing. Yeah, there's a plain old x and there's a plain old x. Okay. So we factored. We cancel the 1s. And what's left over on the top? And what's left over on the bottom? 4. All right. That's the beginning of our cheat sheet. Ooh.